The formula to calculate the future value of an annuity due is future value equals the payment amount times the quantity 1 plus the annual rate divided by the number of compounding periods per year raised to the number of compounding periods per year times the time in years minus 1 divided by the quantity the annual rate divided by the number of compounding periods per year times the quantity 1 plus the rate divided by the number of compounding periods per year. Here is the formula with all of the variables listed. And one important note, to use this formula, the interest compounding periods must match the payment periods, for instance yearly to yearly, semi-annually to semi-annually, or quarterly to quarterly. This is extremely important. So the variable n must match the number of payment periods per year. As a basic example, let's say that someone deposits $3,000 at the beginning of each year for 4 years into an investment earning 7% compounded yearly. What is the future value of the annuity due? Plugging into the formula, we have future value equals $3,000 times the quantity 1 plus 0.07, the decimal value of 7%, divided by 1, raised to the 4 times 1, minus 1, divided by 0.07, divided by 1, times 1 plus 0.07, divided by 1. Here are all the steps with all of the calculations written out, and we end up with $3,000 times 4.4399, rounded off, times 1.07. And this calculates to a future value of $14,252.22, rounded off. Now, as another example for when the payment periods do not match the compounding periods, let's say this time that someone deposits $3,000 at the beginning of each year for 4 years into an investment earning 7% compounded quarterly. What is the future value of the annuity? So the interest compounding periods are quarterly and the payment periods are yearly. We need to get the compounding periods to match the payment periods. To do this, we need to convert the nominal interest rate of 7% to the effective rate. And the formula for this is effective annual rate equals the quantity 1 plus the annual rate divided by the number of compounding periods per year raised to the number of compounding periods per year minus 1. Now we can plug into the formula, and I've done all the calculations. We get the effective rate equals 7.1859%, rounded off. And now we can calculate the future value of the annuity due using the main formula. We have future value equals $3,000 times the quantity 1 plus 0.071859, the ER, or effective rate, divided by 1, raised to 1 times 4, minus 1, divided by the quantity 0.071859, divided by 1, times 1 plus 0.071859, divided by 1. Again, calculations are on the screen, and this calculates to $14,316.22, rounded off. If we compare it to the previous problem, the annuity that compounds quarterly has a higher future value, and that makes sense because of more compounding periods or the higher effective interest rate. One last example. This time someone deposits $500 at the beginning of each month, again for 4 years. The yearly rate is 7%, but is compounded quarterly. What is the future value of the annuity? So again, the compounding periods do not match the payment periods. Monthly payment or deposit periods and quarterly compounding periods. To do this problem, we have to first convert the interest rate to the effective yearly rate, then second, convert it to a nominal rate. So first, to convert to the effective rate, we have effective rate equals the quantity 1 plus 0.07 divided by 4 raised to the 4 minus 1. And the calculations are on the screen. We get effective rate equals 0.071859, same as the last example. Now for the nominal rate. We have nominal rate equals 12, the number of compounding periods, it's 12 because we need to match the monthly deposits, times the quantity 1 plus 0.071859 raised to 1 divided by 12 minus 1. I've done the calculations on the screen, and we get nominal rate equals 0.069596. And now we can calculate the future value of the annuity using the main formula. We have future value equals $500 times the quantity 1 plus 0.06959561 divided by 12, the number of deposit and compounding periods, raised to 12 times 4 minus 1 divided by the quantity 0.06959561 divided by 12 times 1 plus 0.06959561 divided by 12. Here are all the calculations written out on the screen, and this calculates to $27,741.85, rounded off. Alright my friends, hopefully you got something out of this video. I do have more videos right there for you. Till next time, I am out of here.